Kirk math. Hey, here we are, 11.3, our last lesson of Module 11. We're going to take a look at identifying if triangles are similar to each other by comparing their angles. And we're going to use a lot of the information that we've done in our previous lessons to help us identify if these triangles are similar or not. All right, first thing in your notes is to write down your key terms. So first we need to remind ourselves what similar figures are. Similar figures have the same shape but may have different sizes. Similar triangles are basically similar figures, but specifically they have corresponding angles that are congruent and their lengths of their corresponding sides are proportional. So having this word corresponding in here, we've talked about corresponding angles a lot. And I will pop up a slide here to talk a little bit more, but basically it's like that same general location. So in this image, the colors are corresponding. So this green corner of the smaller triangle and this green corner are corresponding. And we know that because this little triangle or little arrow means that these lines are parallel. So you can think of the sides of this triangle as transversals that are cutting through these parallel lines. And so we can think of that same thing that we did before with the parallel lines and the transversals and looking for corresponding angles. So again, corresponding angles are ones that hold the same relative position as another angle somewhere else in the figure. So these two triangles are nested inside each other. Okay, I know that this pink triangle corner, those are corresponding and they are the same because they're overlapping. And then you've got these corresponding angles here and these corresponding angles here, the greens and the blues. Okay, so going back to our definition, they have corresponding, their corresponding angles are congruent and the lengths of their corresponding sides are proportional. So what that means is if I were to make a ratio of this smaller triangle over the larger triangle, we don't know what, hold on, let me fix that. We don't know what the size of the sides of the larger triangle is here. But they need to be the same ratio as the other side lengths that we have here, which is 12 plus x, and the side lengths on the bottom, which is 15 to 25. So again, corresponding means that it's in the same relative position. So this 18 centimeters is corresponding to the whole side here on the left because it's the side between the pink and the green angles on both triangles. Okay. Same here. 12 plus x is corresponding to just the 12 here on the little triangle because it's between the pink and blue corners of our triangle. Okay, so that's kind of how we know if they're similar. And we're going to learn and focus about one main thing that's going to help us identify if our triangles are similar or not. Okay, so we are going to focus on the angle similarity postulate. And angle or AA refers to the fact that if two angles of one triangle are congruent to two angles of another triangle, then they are similar. Okay, so if I can prove that two angles on this triangle ABC are congruent to the two of the triangles on triangle DEF, then I can prove that these two triangles are similar. So we're going to go back and use our triangle sum theorem, knowing that the angle of A plus the angle of B plus the angle of C is going to be 180 degrees. So same over here. D plus E plus F is 180 degrees, and we are going to find these missing angles, okay? And if I can prove that two of the angles are the same, then I know that these triangles are similar, okay? The reason that they're similar and not just congruent is because I'm only looking at angles and I don't actually know what their side lengths are. So one of these triangles could be bigger than the other or smaller than the other. So we're just focusing though on our angles. Okay, so we're going to do the first triangle ABC first. So I already know that angle B and angle E are congruent. So I can already say that angle B is the same as angle E. So what I need to figure out is angle C the same as angle D? Or is angle C the same as angle F? I need two angles to be the same. So I need to figure out what C is and what D is so that I can compare the other four angles. So over here on angle ABC, I'm going to do 100 plus 45 plus C equals 180, and I'm going to solve that. So that's 145 equals 180, subtract, and I'm going to get C is equal to 35. Okay, so I know that angle C is 35 degrees. And at this point, I could stop because B and E are congruent and C and F are congruent. I know that yes, the triangles are similar. And I know that because if I add all three of these angles together, it's going to equal 180, and that's the same thing on this other triangle as well. And so if 100 plus 35 plus this other angle is 180, then we also know that angle D and angle A are also 45 degree and similar as well, or congruent as well. And so because I'm not looking at side length, I can confidently say that these triangles are similar. If I knew their side lengths, then I could identify more if they were actually congruent or just similar, and I can confirm that. But according to the angle similarity postulate, these two triangles are similar. So let's start solving some problems using similar triangles to help us solve some problems. So here we have, while playing tennis, Matt is 12 meters from the net. That's where we're getting this number here, which is the net is 9/10 meters high. He needs to hit the ball so that it just clears the net right here and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? So we want to know, how high does he need to jump? What is the height that he needs to make contact with that tennis ball? So this formation basically makes two triangles. We've got the triangle formed by Matt himself and the position he needs to hit the ball. And then we have a mini triangle formed by the net itself and the position he needs to hit the ball. And so because we know that A is the same in both triangles because they both share this point, and we know that both the net and Matt, the measurement of this vertical line here by Matt, are 90 degrees, we know that they're similar triangles, so we can start messing around with these. We also know that similar triangles have proportionate side lengths, so we're going to use that information to figure out the height that we need, okay? So again, proportional means that the measurement of the side of one of my triangles compared to the measurement of the side of my other triangle should be the same for all three sides, whatever it may be. Okay, so we're looking kind of like at ratios or similar ratios. So I'm going to circle the things that I know. So I know this is 6 and I know this is 12, and that's just from B to D. So from A to D, the total length is 12 plus 6, which is 18 meters. So the length of the large triangle is 18, or the base of the large triangle is 18 meters, and the base of my small triangle is 6 meters. So I am going to go big compared to small, and 18 divided by 6 is 3. Now I need to, because I know these are similar, the ratio of my big triangle, this height here, to my little triangle should also be 3. So I need to make the height of this triangle compared to the height of the small triangle equal to 3. And oh my goodness, we've seen this in our warm-ups recently. This is solving a problem with division. Yes, it kind of looks like a fraction, but this is just a division bar. So what I'm basically going to do is multiply 9/10 on both sides. And that is going to help me solve down here. Now, if you don't want to multiply 3 times 9, you can use a calculator. 3 times 0.9 is 2.7. So the height that Matt should hit the ball should be 2.7 meters off the ground. And that's it. Okay? I know that these triangles were similar because angle A was congruent to angle A, and angle B and angle D are congruent. That means that the side lengths of my triangle are proportional. So because the total length of this triangle was 18, divided by the total length of the small triangle, 6, that means that my proportion is 3. So I have to make that same proportion with the other measurements I need to find. All right, we're going to try the similar problem again. So we have Rosie is building a wheelchair ramp that is 24 feet long and 2 feet high. So again, 24 is the length of the big triangle and 2 is the height of the big triangle. She needs to install a vertical support piece 8 feet from the end of the ramp. What is the length of the support piece in inches? Again, I know that this is a similar triangle because this corner piece is the same, and both of these are going to be right angles because we're looking at height. So I know that I can look at the ratio and proportion between the side lengths. Okay, so I am given the side length of both the big triangle and the small triangle, and I'm going to divide that there. 24 divided by 8 is 3. So that means that, again, my big triangle divided by my small triangle should equal 3. So we're going to do the math and figure this out. So I multiplied both sides by h so that I could move the h out from underneath the 2. That gave me the equation 2 equals 3 times h. Then I divided both sides by 3, and I got 2/3 of a foot. So the height of this little support piece should be 2/3 of a foot tall. All right, and the last 2 questions are your independent practice questions. So see if you can remind yourselves, how can I explain whether these 2 triangles are similar? And how can I answer the question here when the lower cable of this tree meets the tree at a height of 6 feet and extends out 16 feet from the base of the tree? If the triangles are similar, how tall is the tree? So what it's basically saying is this lower cable here, it meets the tree up here at 6, and it extends out 16 feet. So I know that this is 6 and 16, but what I don't know is the height of the total tree. So see if you can use similarity, triangle similarity, because it tells us the triangle, if we assume the triangles are similar, to find the height of the tree. So pause, do these 2 problems, and then meet back up with me to see your answers. All right, so for the first 2 triangles, you should have gotten no, they are not similar. Yes, they both have 70 degrees as one of their angles, but when I solve for the third corner Q on the right triangle, I got 61 degrees, which does not match on an angle on the left. When I solve for, just a triple check, I solved for the angle N on the left triangle, and it equals 52, which again does not match a second angle on the other triangle. So because only one angle is congruent, these are not similar. Down on the bottom, I set up actually a proportion, which I didn't do before. You can still do the 56 divided by 6 and then set that equal. But if you set it up as a proportion with the ratio of the bases equal to the ratio of the heights, then you can cross multiply. So I did 56 divided by 16 here. So I did 56 times 6 to get 336 and 16 times x to get 16x. Now I have an equation, 16x equals 336, and I should know to divide both sides, and I got 21. So the height of this tree is 21 feet. And that's it. Good luck.